Hello? 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 Okay, so let us work on this problem again. Let us work on this problem again. The first problem we started. So now this is the problem of inverse Fourier. So we need to find the inverse Fourier, which means we need to find the Fourier transform of this function. Now we look in the table and we find that the closest uh, inverse transform pair that there is an omega t divided by 2. So I just need to do the next step is to just bring this in this form. So I have 2 sine 3 omega. So if I divide it by 2, I have to multiply by 2. So it will be 6 omega divided by 2. And the 4 multiply by the frequency shift, which is j 2 pi t. So this is my result. All right. Okay, now let's look at the second problem with 3. So obviously there is a shift of pi by 3 here. So I will write cosine 4 omega. I take omega common and inside it will be, sorry, I take 4 common. So inside it, but the first step is to find the Fourier transform of cosine 4 omega. So the first step is to find the Fourier transform of cosine 4. On the right hand side, there is no Fourier transform which is cosine 4 omega. But however, I have a Fourier transform. So if the positive frequency is the right shift, so the negative frequency is, if we combine these two, I have cosine 4 omega. So on the left hand side, I have 1 over 2 delta t plus 4 plus 1 over 2 delta t minus 4. So that is, and that will be e raised to j4 omega divided by 2 plus e raised to minus j4 omega by 2, and then add them and you will get cosine. All right. So now this is half of the question. The other half is if the shift is plus, if the shift is, if there is a shift of frequency, and this is the result, the final answer. Now I think in the solution there is a small mistake, so please make sure that you solve it like this, which I am solving here. If you have any question, you can ask in the group and I will answer you right away. All right. So the third question is that the C part of this is plus 3 delta omega minus 2 pi plus delta omega plus 2 pi. So by just looking at this, we can see that this is the Fourier transform of cosine and sine. Why? Because let us look at these. Let us just cosine omega naught t. Cosine omega naught t. The Fourier transform is 1 over 2. Okay, so it is pi delta omega minus omega naught plus. Worry about the constants. Constants we can adjust. There is a constant here, we can adjust it. But we just need to find. We just need to see if there is a plus or a minus. If there is a negative, then right. First of all, I can write it without the 2. So I know that pi over j delta omega minus 1 if I have 2 here. So I need to replace this by 2. So what I do is I multiply and divide. So I multiply this by pi and divide it by j. So yeah, let us just do it again. So I multiply and divide by uh, according to this pi pi over j. So it is uh, plus pi delta omega plus 2 pi. So I just multiply and divide it by 3 over pi. This will cancel and the function will become 3. What is the total x of t? The total x of t is the combination of these two. So x of t here will be equal to, this brings us to the end of the problem number 2. Now let x of t and h of t in time corresponds to the multiplication. So which makes things very simple, which makes these questions much easier than the convolution, because convolution takes a long time. So which means that if I have x of omega here and h of omega is the Fourier transform of h of t, then y of omega. So this is called the property of convolution. And now what will be y of t? Y of t will be just the inverse Fourier transform of y of omega. So let us do this question, and it will be more clear when I do this question. So um, uh, to the Fourier transform table. So you need to have this table all the time. Whenever you are doing questions, you have to the relation, which is t e raised to the power minus at plus j omega, which is 1 over 2 plus j omega. So now y of omega, which is the multiplication, will be just x of omega 2 plus j omega. Need to separate them. So this is done by the partial fractions. So I can write the partial fraction of this, a over 2 plus j omega, 1 over 4 plus j omega. Now, in this course, we are not, I can write the another one, the other one, which is e to the power minus at u of t. The Fourier transform of this is 1 over a plus j omega. So, and you know, we don't need to use the integral. So in this course, we just use the table. Problem 4. Problem 5. This is just a bit more on it. So let us do that question, C part. So problem 6, and e raised to the power j to t. So as I can see, we can see here that it is, so problem 7 is not included. Problem 8, my x, this is 0, and I have 2 impulses. So I can just write it. So it is just j omega multiplied by 1, and delta t plus 1 will be e raised to the power minus j omega minus 1. So if I add the 2, it is just, yeah, but I also need omega. Yeah, so the second part of this question, 8, second part, is just, I can write plus 1 over 2 delta t minus 5. And I can just write down these exponentials for each of them. And this is, there is no shift, so it is just 1. So x of omega will be just equal to, this is 1. We left in the lecture number 8. So if I go to lecture number 8, property number 7, that is the property of, which is the property of Fourier transform. And I go to the property number 7, which we left in the last lecture. And that is the property of duality, which is a very nice property and a very strong property. Many Fourier transforms can be determined by this property. So this property says that is x of omega, then the Fourier transform 2 pi rectangular t omega divided by, bring the Fourier to the time and time to the Fourier. So this is the property. So in other words, it means that the Fourier transform of a rectangular pulse is sinc. And the Fourier transform of sinc is the rectangular pulse in time. So now we go back to the problem set and we go. Yeah, I think I left one problem there. Problem number 8. Uh, yeah, I can just delete this here. So problem number 11 is x of t is 1 plus 9t square. And I need of this type. So I look at the left hand side, I don't find anything. So if I don't find anything on left side, then I have to look to the right side and find the closest value. And on the right side, I can find this Fourier transform, which is e raised to the power minus at, and that is the double exponential. And the Fourier, this one is same as this, but t replaced by omega. So which means that I can find it, the Fourier transform of this, by applying the duality. So, but first of all, I need to, because this is omega and this is 9t square, so I need to, I bring this in this form. So I have 1 over 1 plus 9t square, and that is equal to, I take 9 as a common factor, so it will be 1 over 9, 1 plus, yeah, I take 1 over 9 as a common here, so there is 9, right, plus t square. So I have t square. No, sorry, because when I multiply it by 9, it will be 1 plus 9t square. Yeah, that's fine. Now still I have 1 over 9, 1 divided by 2 by 6. So I have to multiply it by 6 over 2. So that this is exactly equal to this function here. Now they are exactly equal. So, and I can write the Fourier transform of this. So this is, so I can just, yeah, so I have it here, a constant, which is 1 over 9, 6 over 2, so this is 3, 2. So 2 over, this is 2 over 3, 3 by 9, so 1 over 3. I have 1 over, right? And that is, this is exactly same as this, and 1 over 3 is just a constant. So the Fourier inverse of this is minus a is 1 over 6, so 1 over 3. 2 over 3, I'm sorry, there is a mistake here. So it should be 2 over 3 and 3 over 2. So then it will be, sorry, there is a small mistake here. So it should be 2 over 3, but if I multiply it by 2 over 3, I also need to divide it by 3 by 2. So 3 by 3 cancels, and this is 1 over 6. 1 over 6. 6, and this is 2 by 3. So now a is 1 over 3, so it will be e raised to the power 1 over 6 e raised to the power minus 1 over 3 t. Alright, now I can bring the whole thing here and replace it by omega. So 2 over 3 divided by 1 over 3 square plus omega square. I need to yeah, this is I replace it by omega. X of t is x of omega. Yeah, actually this is omega square here. So let us do it once again. So let us start from here once again. So I need to bring this in the form of this from this function. So that will be equal to, so I have 1 over 1 plus 9 omega square. So I need to bring this in the form of this omega, so that I can apply the rule. So this is equal to 1 over 9, 1 over 3 square plus omega square. So I need to multiply it by 2a. So a is 1 over 3. So I need to have 1 over 3 in the numerator. So I have 1 over 9 whole square plus omega square. But if I add this term here, I also need to multiply it by 3 over 2. So this is equal to 3. So this is equal to 1 over 6. So now this is same as this. So I can find the inverse of this. So when I bring all of this here, it will be 1 over 6, 2 by 3, 1 over 9 plus omega square, t square. I just change it to t. I can just change this to t, and I can bring this on this side. On this side, it will be 1 over 6 e raised to the power minus 1 over 3 omega. Again, so 1 over 6 multiplied by 2 over 3 and multiply by, I can just multiply it over 1 over, I can just multiply it by 9 once again. So 9, sorry, so 1 plus 9t square. So I multiply it by 9 and also 9 here and 9 here. So it will be 9. So on this side I just multiply it by 9. And this is equal to 3 over 2, 3. So this is the Fourier transform of, and this is actually all cancelled. So this is my result. So in the bottom line, the result is this. So 1 over 1 plus 9p square. The result is just 3 by 2, 3 omega. Right? So this is the end of this lecture. I will give you a problem set. Now what I will do here, I will give you uh, uh, so what will this problem, this homework will be 10 marks. 7 marks will be given on your homework, and 3 mark will be a quiz which will be on Thursday on the same problem, similar problems. Okay, on the similar problems which will be in that homework. Okay, so more instruction I will give on the WhatsApp. Okay, thank you for watching.